Hi, welcome. This is a lesson on the quadratic formula, using the quadratic formula to solve quadratic equations. The quadratic equation needs to be written in the form ax squared plus bx plus c. We need to modify that just a little bit. It needs to be written in the form, it's called standard form, and it's ax squared plus bx plus c equals 0. It needs to be equal to 0 on the other side. And it has two solutions. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a, and the b squared minus 4ac is the discriminant that we talked about. It has two solutions because of that plus or minus in the middle. There's a plus value and a minus value, and it gives you two solutions. So just real quick review here. B squared minus 4ac, the discriminant, has the following possibilities. It's positive would indicate that there are two real solutions. 0, if the discriminant is equal to 0, that means there is one real solution. And if it's negative, that means there are two non-real solutions. And we'll see some examples of all of these here moving forward. All right, here's the steps. First, make sure that it's in standard form. Once again, ax squared plus bx plus c equals 0. You want to write down the values of a, b, and c. You want to substitute a, b, and c into the quadratic formula. Find the discriminant first here, and then simplify the radical, reducing if possible. And if there's more than one answer, write each answer separately. Some hints. Check your first term sign is opposite of b in the equation. Remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac. This is all over 2a. And so what this is referring to is make sure that this number, once you've evaluated, you've substituted it into the formula, that you're putting the opposite of the value. And so if b equals 4, here you're going to put negative 4. If b equals negative 7, you're going to put positive 7, or you can put negative 7 and then change the sign afterwards, multiplying the signs. All right. Only reduce at the end if you can factor a greatest common factor from the numerator that will reduce with the denominator. We'll see some examples of that moving forward here. Let's look at this first one. 3m squared plus 16m plus 5 equals 0. Let's go here and say a equals 3. Clean that up a little bit. A equals 3. Oof, it's coming. 3. B equals 16. And C equals 5. And so the discriminant is b squared minus 4ac. We put b, which is 16, squared, minus 4 times a, and a is 3, times c, and c is 5. And if you just put this in your calculator, you get 196. And then we can go to our formula. X then is equal to negative b, that's negative, and since b is positive 16, that's negative 16, plus or minus the square root of the b squared minus 4ac. We've already figured it up, and it's 196. And this is all over 2 times a, and a is 3, so that's 2 times 3. Well, the square root of 196 is equal to 14. It doesn't always come out that nice and neat. If we need to simplify it, then we will, making a simplified radical like we have done in prior units. So I can then substitute in, I've got negative 16 plus or minus 14 all over 2 times 3, which is 6. And this gives us two values here, negative 16 plus 14 over 6, and that's negative 2 over 6, and negative 2 over 6 simplifies to negative 1/3. And then the other value, so we've got the plus side, oops, the plus side, and then we also have the minus side, and that's what this one is going to be down here. So I've got negative 16 instead of plus 14, minus 14, and this is over 6. And negative 14 minus negative 16 minus 14 is negative 30 over 6, and that divides out evenly to negative 5. And so our x values, our solutions, are negative 5 and negative 1/3. And those solutions came out really nice. They don't always do that. Let's look at B. A equals 1, B equals 4, and C equals 7. So our discriminant, b squared minus 4ac, b is 4 squared minus 4 times a, which is 1, times c, which is 7. And if I put that in my calculator, I get negative 12. And that's going to be the part under the radical. So I'm just going to go ahead and simplify that and see what it looks like. That's going to be the square root of negative 12. And so just like we set up here above, when the value of your discriminant is negative, you get two non-real solutions. Because if you have a negative under the radical, which we do here, it comes out of the imaginary. It comes out of from under the radical as the imaginary unit I. And so I've got 12. I'm going to just say 12 is 2 times 6, and 6 is 2 times 3. So I have a pair of 2's that's going to come out as a 2. And so this is equal to 2. I is the negative. I comes out as the negative. The negative under the radical comes out as the unit I, square root of 3, the 3 that is left. And so then I can put this in the formula. X equals negative b. X equals the opposite of b, which is negative 4, plus or minus the square. And here I'm just going to go ahead and put, instead of the square root of b squared minus 4ac, I'm going to put plus or minus 2i square root of 3. That's the square root of negative, where the square root of negative 12 would have been. I've simplified it already. And this is all over 2 times a, which is 2 times 1. And I'm going to separate this into two parts right now. I've got negative 4. I'm going to take that 4 and that 2 in the numerator and factor out a 2, because in the bottom, 2 times 1 is 2. So they have a 2 in common. So I'm going to take and write this as 2 times negative 2, gives us the negative 4, plus I square root of 3. And this is all over the denominator, which is 2 times 1, or just 2. And I factored that 2 out because now I can say, hey, those can be simplified. 2 divided by 2 is 1. The 2 that I factored out, if I multiply it out, you could see that it gives me the original. 2 times negative 2 is negative 4, and 2 times I rad 3 is 2I rad 3. I'm going to do the same exact thing over here. 2 times negative 2 minus I rad 3, this time a negative instead of the positive, all over 2, and the 2's cancel. And so my solutions are negative 2 plus I rad 3 and negative 2 minus I rad 3. And those are my solution sets. Or those are the two solutions. All right, let's go to example C. Now I notice in example C that this is not in standard form. And so I'm going to rewrite it as 2w squared minus 4w. I subtract 3 from both sides, gives me minus 3 on the left, and on the right, 0, because 3 minus 3 would be 0. Now that's standard form, and I can say A is 2, B is negative 4, and C is negative 3. And so to calculate my discriminant, B squared minus 4AC, B is negative 4 squared minus 4 times A, which is 2, times C, which is negative 3. And again, if you put that in your calculator, you get 40. This time, I mean, just to not confuse you, I will not skip steps here. I'll put x equals negative b. Now this time b is negative 4. So the negative of negative 4, and you can just write that, the negative of negative 4. And then multiply the signs, which give you positive 4, the opposite of the b value. Plus or minus the square root of 40 from the discriminant 40. And this is all over 2a, and that's 2 times a is 2. Now, I'm going to go over here to the side and simplify the square root of 40. The square root of 40, I'm going to take off to the side, right? 40 is 2 times 20. 20 is 2 times 10. 10 is 2 times 5, and 5 is prime, and so I can say there's one pair of 2's, and that's it. That's going to come out from under the radical as a 2, and the 2 times 5 stays under the radical as 2 times 5, or 10. So square root of 40 is the same as 2 square root of 10. It's just simplified. Now, because I have a 2 that I can simplify out there, I have a 2 that I have brought out from under the radical, I'm going to leave this as 2 times 2 and write this as my 4. I'm going to write it as 2. Let me write a middle step here so you can see what I'm doing. Negative times negative is positive, so that's 4. Plus or minus, and then the square root of 40 is 2 square root of 10. And this is all over 2 times 2. And I'm going to leave that as 2 times 2 because in my numerator, 4 and 2 both have a 2 in common. And so I can write this as 2 times 2 plus square root of 10. If I multiply these out, 2 times 2 is 4, and 2 times square root of 10 is 2 square root of 10. And so that's factored, and that's all over 2 times 2. Now, the fact that I have a 2 that I've factored out, I can write that, I can cancel that with one of these 2's down in the bottom. And so that would be one of my answers. And then the other answer, I'm going to do the same thing, 2 times 2, but instead of plus square root of 10, I got minus the square root of 10. And this is all over 2 times 2, and once again, the 2's cancel. So my two solutions are 2 plus the square root of 10 over 2, and 2 minus the square root of 10 over 2. All right, let's look at D. Now, D is in standard form, but this time we see a negative in the front, so A is negative 1, and B is 4, and C is negative 4. So my discriminant is B squared minus 4AC, and B is 4, so I get 4 squared minus 4 times A, and A is negative 1, and C is negative 4. And 4 squared is 16. And then I've got a negative, negative, negative. Those all, if you have an odd number of negatives in a multiplication like this, the result will be negative. And then 4 times 1 is 4, and 4 times 4 is 16. So I've got 16 minus 16, which is 0. Our discriminant is 0. Recall from what we shared up above that if your discriminant is equal to 0, you're going to have one real solution, and we're going to see why that is right now. So x equals negative b, that's negative, or the opposite of b, which is 4, so negative 4, plus or minus the square root of 0, and this is all over 2 times a, which is 2 times negative 1. Now, the square root of 0 is equal to 0. So if I'm adding 0 to a number, it doesn't change it any. If I'm subtracting 0 from a number, it doesn't change it any. So this essentially, both the plus and the minus versions, I can just sort of ignore them. They're not changing it any. What I get then is negative 4 divided by negative 2, and a negative divided by a negative is positive, and 4 divided by 2 is 2. And that's it. That's the one solution that you get for this example, because our discriminant was equal to 0. All right, E. Now, you look at one like E, and you've got r squared plus 9 equals 0. And our standard form is ax squared plus bx plus c equals 0. In this example, instead of x, we're using r. And up here I see another term that has an x in front of it. So I should have a term here that has an r, and I don't see one. And then c would be my constant, which would be 9. So I need to rewrite this. I've got r squared plus something plus 9 equals 0. And I ask myself, what would I add? What do I add to a number that doesn't change its value? And if I have 3 plus some number equals 3, that number has to be 0. And so essentially I'm going to add 0 here, but I'm going to write it as 0r, just so that it looks a little bit like what we have in the standard form. And then I can say that a is the coefficient of my first term, which is 1. A is 1. And b is 0. And c is 9. That's positive 9. And so my discriminant, b squared minus 4ac, b is 0 squared minus 4 times a, 1, and c, 9. And 0 squared is 0, so I've got minus 4 times 1 times 9 is negative 36. Once again, because we see that negative discriminant, we're going to have two non-real solutions. So x equals negative b, the opposite of 0 is still 0, plus or minus the square root of negative 36 over 2 times a, and a is 1. This 0 doesn't change anything. So you're going to have a plus value and a minus value of your square root of negative 36. Now the square root of negative 36, this time 36 is a perfect square. That's 6 squared. And so it's going to come out just as a 6, but the minus is going to come out as an I. And so you're going to come out here, this is the same as 6I. Now, I have plus or minus 6I over 2 times 1, or 2. And then that's the 2 divides into the 6, and you get plus or minus 3I. And so our solution set is negative 3I and positive 3I. All right, let's look at F. Now this time, I don't have a constant term. I've got this square, u squared, and I've got u, but I don't have a constant term on the end. So once again, we're going to rewrite that as 6u squared minus 2u plus 0 equals 0. And so that helps us to see that a equals 6, b equals negative 2, and c equals 0. So our discriminant, b squared minus 4ac, is b, which is negative 2 squared. When you have a negative value for b, make sure that you absolutely remember to put that in parentheses, because otherwise it's going to tell you that the result of negative 2 squared is negative 4, and it's not. It's positive 4, because a negative times a negative is positive, but it doesn't square the negative if you don't put it in parentheses. If you just have negative 2 squared, you put that in your calculator, it's going to say that that's negative 4. And that's correct. It's just that that's negative 2 times 2, because the exponent 2 only applies to the 2. All right. We want to square the number and its sign. Negative 2 times negative 2 is positive 4. Minus 4 times a, which is 6, times c, which is 0. And multiplying by 0 takes this term here and just cancels it. And we get negative 2 squared, which is positive 4. So we're going to have two solutions, because our discriminant is equal to a positive number. So we get x equals negative b, or that's negative of negative 2, plus or minus the square root of 4 all over 2 times a, which is 6. And I'm going to simplify this just a little bit. Negative 2 is positive 2, plus or minus the square root of 4 is 2 over 2 times 6, which is 12. And then we can separate this out into two numbers here. We've got 2 plus 2 over 12. That's 4 over 12. And that simplifies to 1/3. And then I've got 2 minus 2 over 12. And 2 minus 2 is 0 over 12. And 0 divided by 12 is 0. And so our solution set, x, is 0 and 1/3. And that's it, I believe. Practice. You're going to do just fine.